Hey, welcome back to Fat Mama Physics. In this video, it's part 2 of 6.2, which is reductions, taking something really big, scaling it down to something small that you can fit on a piece of paper so then you can talk about it. Good examples are telescopes. We use telescopes to look at objects far away in the universe, and then we can grab a small picture of it, talk about it on a sheet of paper, share it on internet as a picture, and do further analyses with that. Another good example is if you like to go to, say, open houses, they will usually give you a layout plan of the house. Of course, the house itself is bigger than whatever you see on the page. So the page is whatever's in real life scaled down, reductions. And the common theme is that for your scale factor, for reductions, your scale factors will always be less than 1 for it to be a reduction. Okay, so I'm going to find my pen. Here's a question for you. Haha, good. Let me ask you this question. What would you expect if your scale factor was 1? Here, I'll ask you the question again. What would you expect? What does it mean for your scale factor to be equal to 1? Good time to pause the video and think about it. So if you say that a scale factor 1 means that there is no scaling, then you are correct, meaning that your original size is exactly the same size as your copy. So what a scale factor 1 means, if I take my original copy, I scale it by multiplying by 1, I'm going to get my copy. Anything times 1 is the same number. So there is no scaling if I have a scale factor of 1. Notice the number is not 0. If I multiply something by 0, I get nothing. Imagine my scale factor of 0. Something multiplied by 0, I get nothing. That's funny. Sorry. So that's what it means to interpret numbers in math. You have to make sense of it. And math tends to be fun when you start applying it. So let's do some applications with this scale diagram of this truck. With my truck, okay, this is a top view of the truck. Here's a scale diagram. So this is the copy. We're seeing the copy right here. This truck that you see here, it's a picture of the actual truck. The actual truck length is 3.25 meters. That's not very long. That's like 3 steps, basically. 3 big steps for someone taller in our class or something. The scale is 1 to 50. Means that 1 centimeter on my diagram represents 50 centimeters on the truck. And if you don't remember ratios can be represented by fractions. So if I write this as a fraction, this is 1 over 50. 1 over 50 is a number less than 1. So we know we're talking about reductions right now, okay? This means a 1 centimeter, blah, 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 blah. So the scale factor, copy of image, is 1 centimeter over 50 centimeters. Oh, we should calculate that what it is. I totally should remember. I'll tell my 0.02. So 0.02, in fact, is going to be our scale factor. On the actual truck, the front and back wheels are 2.7 apart. So that's basically from here to here. On the actual truck, it's 2.7 meters apart, okay? How far apart should the wheels on the scale diagram be? Make sure we use the same units. Oh, okay, so absolutely. Each distance on the scale diagram is 1 over 50 or 0.02 of its distance on the truck. So that's our scale factor. Now we gotta make sure we convert this 2.7 meters into centimeters, because on our copy, the picture of the truck you see on your page can be measured in centimeters. We can't really do that we could do that in meters, but let's work in centimeters. Probably easier for you to visualize as well. So 2.7 meters to centimeters, and if you're thinking you got to multiply by 100, you are correct. So I multiply 2.7 by 100 gives me 270 centimeters. So we're going to convert, so in order for us to figure out the copy, remember our equation, scale factor is equal to copy divided by original. If I want to figure out the copy, I need to take the original multiplied by my scale factor. So my scale factor, which is 0.02, I multiply this one by 270 centimeters, and this is going to give me 5.4. This is going to give me 5.4 centimeters, which means on the scale diagram, the copy that I have here, the wheels must be 5.4 centimeters apart. Okay? All right, here's the first part. Hey, what's this here? This is talking about the width of the actual truck. What is the width of the actual truck? Oh, I have to measure the width of the truck on the scale diagram? Oof. Well, I guess maybe you could measure it on yours and make a number, but guess what? I'm gonna make a number. What number should I make? Let's see. If this is 5.4 centimeters, I'm gonna roughly estimate that this length over here, let's do it in green. I'm gonna say that's 4 centimeters. How's that? This is 4 centimeters. Makes our math a little easier too, hey? So I'm going to say on the scale diagram, this is my copy. Okay, my copy is 4 centimeters. So the actual measurement is 50 times greater on the scale diagram. So the actual width of the truck is 50 times 4 centimeters. Because what that means is my truck, my actual truck, is 50 times greater than this diagram here. Because it's a ratio of 1 to 50, right? So basically what I have here is 1 centimeter on my diagram is going to be 50 centimeters on my actual truck. So 4 centimeters on my diagram is going to be what number over here? So I go 1 times 4 is this. So 4 times 50 is going to be 200. 200 centimeters is equivalent to 2 meters. Or here, 200 centimeters is going to be 2 meters wide. Okay? So that's the idea. Now, you notice that I did some multiplication here to go the other way. There's another way you can tackle this as well. Remember my scale diagram, my scale factor is equal to my copy divided by my original. My scale factor is actually 0.02. We just played with that number a little bit to make it more visual for you. But if you are more mathematical, you like your algebra, you could do it this way to get the same answer. If you want the original size, if you have the copy and the scale factor, what you need to do is you need to get your original up to the top. So multiply by original up here. I get original times SF is going to equal to copy. I divide both sides by the SF, which is going to be my original is equal to my copy divided by my SF. So copy divided by my scale factor in this case. On my truck, my width is 4 centimeters. If I divide it by my scale factor, which is 0.02, then I'm going to get exactly the same thing. So try putting that into your calculator. 4 divided by 0.02 gives me 200 centimeters. If you're really snazzy, you can think about how you can convert a 0.02 into a fraction. If you're dividing by a fraction, if you multiply it by the reciprocal, you get exactly 4 centimeters times 50. Hoo hoo hoo, playing with your math, eh? If you're a triangle person, then you might use this instead. Original is copy divided by scale factor. Whichever way works for you, okay? They all give you the same thing. So really, these scale diagrams, you just kind of have to, as long as it makes sense, it doesn't matter what math you use, okay? You just saw this. There's so many ways to do the same thing. Which means, in this next part of the video, you can try to figure out this table as an example. Here's the original size, the copy, and the scale factor. And oh, hey, look, there may be, you're going to have a mixture of examples from enlargements to reductions. You have numbers greater than 1 or less than 1 are all in here. So expect all sorts. And guess what? If you're really snazzy, you can even go in here and tell me if this is an enlargement or this is a reduction because of your scale factor number, okay? So good time to pause video to fill out the table. Okay, then it is my turn to do it for us. So here, I have length of my original and the length of my copy. Oh, here. So here's my scale factor, copy, original, and the scale factor is here. Okay, that's my equation. To get my scale factor, if I have original and copy, I take copy divided by original. So that is 24. centimeters divided by 12 centimeters, I am going to get 2 for my scale factor. Since this is larger than 1, this is an enlargement, okay? Or notice my copy is bigger than my original. Here, the next one, I have a scale factor of 4, meaning my copy is going to be 4 times greater than my original. So I take this and I multiply this by 4. This is going to give me 36 centimeters. Notice the units must match. Next one is a little bit different. I have the scale. Oh, I forgot. This last one was an enlargement. So this is a scale up again. The next one is also going to be scale up because I have a scale factor greater than 1. This is also an enlargement. But now I have the copy, okay? So my copy is going to be bigger. My original is going to be smaller. So I need to take my copy and divide it by this big number, a number greater than 1, to get my smaller original. So this is 48 centimeters divided by 1.5. The reason is stated in my last example with the width of the actual truck. You can go over that example again to figure out why I did that. It's exactly the same reason and the math. So that gives me 32 centimeters. Okay. Next one, I have my original, which is 25 centimeters, but my copy, it is smaller. I still take my copy and divide it by my original, which is 25. This is going to give me 1/5 for my scale factor, or 0.2. So since my copy is smaller, I have a scale factor less than 1. This is called a reduction. Okay? Okay, next I have a scale factor of 0.1, also less than 1, meaning it's a reduction. To get my original, this is similar to what I did up here with I take my copy, which is 10 centimeters, I divide it by my scale factor, which is 0.1, and that's going to give me 100 centimeters. Okay, and again, don't forget, if you really love this triangle, go ahead and use it. I'm not going to cry over it. Copy is up here. Copy divided by scale factor gives you your original. Okay. Last example here. I have a scale factor of 0.6, but now I have the original. Original is down here of my fraction. Scale factor is up here. If I take my scale factor of my original, so I multiply by my original, I get my copy. My copy is going to be 0.6 of 14.7. Notice when I use of, it means multiply. So I have 0.6 times 14.7. I get 8.82. So times 0.6 gives me, 8.82 centimeters. And I have a scale factor that is less than 1. This is a reduction. Phew! All right. So there we go. This is reduction. I think that's it. That's all the examples. So now you should be able to take any diagram, scale it up, scale it down, because you know what enlargement is, you know what reduction is, and then you can pretty much. This is kind of like a little bit of architecture. If you like architecture, if you like layout designing, and guess what? Scaling is such an important topic no matter which branch of science you're talking about. Even in linguistics and whatnot, we all use scale diagrams. It's the idea of scaling is an important topic, so very applicable. So in the next couple of videos, we are going to talk about scaling in terms of shapes. So polygons and triangles and how they are used in history for anything that's, could be for anything, building things, military, and interesting stuff coming up. So I thank you for watching this video. Stay tuned for this unit. Awesome stuff coming your way. Good luck with your practices. Fan Mama Physics signing out.